In this short lesson, we're going to talk about ionic compound hydrates. But before we can talk about the hydrates, we have to review our rules for naming ionic compounds. So, looking at these ionic compounds, and we know they're ionic because we've got a metal and a nonmetal. Now, when we name them, the rules were that you name the metal first and then the nonmetal second with an IDE ending. So this first one would be calcium sulfide. Then we would have magnesium chloride, followed by sodium phosphide, and then potassium bromide. And these are all simple binary compounds. Okay, so now that we've reviewed those rules, now we're going to talk about ionic compound hydrates. Well, what in the world is a hydrate? Well, a hydrate is just a term that's used when a substance has water attached to it. Now, most of the time the water is attached loosely, but it's almost like the water is embedded within the crystals. Hydrates have a unique number of water molecules in their chemical formulas. So something like calcium sulfate might have water molecules attached to it, and in the chemical formula it would tell you how many water molecules. Now, in the solid, these water molecules are actually part of the structure of the compound. So when we talked about sodium chloride, for example, we said that its structure was like a cube. Well, when you have a hydrate, it's almost like the water molecules are just part of the structure of the compound. So the rules for naming ionic compound hydrates are really similar to naming ionic compounds, but with just one thing added on. So rule number 1 says the ionic compound is named first by using the same rules as before. Rule number 2 says prefixes are attached to the word hydrate to indicate the number of water molecules that are attached in the structure. This comes after the ionic name. The formula for the ionic compound is separated from the water formula by a centered dot. So if you look here in this example, we've got an ionic compound with water attached to it. So rule number 1 says name the ionic compound the way we've been doing it. So this ionic compound is barium chloride. Rule number 2 says prefixes are attached to the word hydrate to indicate the number of water molecules. This comes after the ionic name. So we know it's going to end in hydrate because that's what word is used to represent the water. It's kind of like it's hydrated. And a prefix is given to represent the number of water molecules attached. So the prefixes for this are going to be the same prefixes that we used for covalent compounds. So this would be dihydrate. So the full name for this ionic compound hydrate is barium chloride dihydrate. So let's do some practice problems. Remember, the rules state that you start by naming the ionic compound the way we've been naming. So our first ionic compound in number 1 is aluminum chloride. And I'm going to go ahead and name all of my ionic compounds before I name the hydrate part. So the next ionic compound is lithium oxide. Then we have potassium chloride, and then sodium chloride. Now let's name the hydrates. So I'm going to use a different color here, and I'm going to name now all of these water attachments. Well, we know for all of these, they're all going to end in hydrate. So I can go ahead and write that. Now, the only thing left is to add the prefixes. So 2, the prefix for 2 is di. The prefix for no coefficient in front of the water, so a 1, is mono, and yes, you need to write mono. The prefix for 10 is deca, and the prefix for 6 is hexa. So we have aluminum chloride dihydrate, lithium oxide monohydrate, potassium chloride decahydrate, and sodium chloride hexahydrate.